Hello, this is one of the 3 series videos on properties of rational functions. Now I'm going to be doing 3 videos on properties of rational functions. Now for this video we are considering the case when the degree of the numerator of the rational function is less than the degree of the numerator of a rational function. So the other 2 videos will be considering the other 2 cases, that is when the sign you have here is a quality sign, and then the last case when the degree of the numerator is greater than the degree of the denominator. Now, before I start, let me give you a very short definition of what we mean by a rational function. So a rational function, just like the name sounds, ratio, is the ratio of 2 polynomial functions. That is exactly what it means. That's the basic understanding of what a rational function means. So a rational function is just simply a function r of x that can be written as the ratio of 2 polynomial functions, that is q all over x. So as far as the denominator, that is the polynomial function in the denominator here, as far as it is not equal to 0, because when it is equal to 0, then the whole rational function becomes undefined. So this is the only condition that the rational function has to satisfy. So on the properties of rational functions, what exactly do we mean? So we are going to consider like 2 basic rational functions, and then to find the properties, we basically mean finding the domain of the rational function, the vertical asymptote, and the horizontal or the oblique asymptote, whichever one of them applies to the rational function. So the very first rational function we'll be considering today is going to be r of x equals x negative 4 divided by x squared minus 4x minus 32. So for this rational function, we want to find the domain, we want to find the vertical asymptote, and then we want to find either the horizontal asymptote or the oblique asymptote. Now before you begin to do anything or begin to carry out any operation on a rational function, it makes more sense, or it is helpful, if you factorize both the numerator and the denominator before you begin to carry out any operation. So when I factorize this, so that is, this is going to be your first step. So step 1 is to factorize this. So this has been factorized for us. It's just basic. That's x negative 4. And when you factorize x squared minus 4x minus 32, what you obtain is x plus 4 into x negative 8. So this is the very first step. So what we are told to find is the domain of the rational function. So the domain of the rational function. So what exactly do we mean by the domain? The domain of a rational function is the set of all real numbers excluding the numbers which, when I substitute them in the denominator, I'm going to have 0. Because you know, when you have a number like 3 divided by 0, then this number here is undefined. Because you know, you can't have a real number. That makes more sense to be having a 0 as its denominator. So what you'd observe here is, by the time you substitute negative 4 here, the whole denominator here becomes 0. Or when you substitute negative 8 here, when you substitute 8 here, the whole denominator here becomes 0. So that is to say, the domain is going to be the set of all real numbers excluding negative 4 and excluding 8. So this is going to be your domain of the rational function. Now the next one is, we want to find the vertical asymptote. Now how do you find the vertical asymptote of a rational function? Now the very first step to find the vertical asymptote of a rational function is you reduce the rational function into its lowest term. Now what we have here is x negative 4 divided by x plus 4 into x negative 8. Now looking at this rational function here, nothing crosses out, because you have x negative 4 here, you have x plus 4, you have x negative 8 here. So it has no common factor in the numerator and the denominator, so nothing crosses out. So that is to say, the rational function is already in its lowest term, so nothing crosses out. So after the rational function has been reduced in its lowest term, the next step you want to do is you find, or let me just say, the vertical asymptote is the 0 of the denominator of the rational function in its lowest term. So the zeros of the denominator is going to be -4 and 8. So that is to say, my asymptote is x equals -4 and x equals 8. We'll see what all these things, what they really mean in a jiffy. Now the next one is we're told to find the horizontal asymptote. Now to find the horizontal asymptote, it's a little tricky, but you have a very good understanding when I do some little operations here. So now the rational function we are given is x -4 divided by x squared minus 4x minus -32. So this is what you have. Now to find the horizontal asymptote, we need to find, it simply means you're trying to find what the rational function, what it tends to as x becomes infinitely large. That's exactly what it means. Anyway, before I begin to find what x tends to as it tends to infinity, what the rational function tends to as the x tends to infinity, I want to approximate the rational function. To approximate the rational function, I have to consider both the numerator and the denominator. Now when I consider the numerator, the leading term, that is the term that has the highest degree, is x. So I'm going to write x divided by, and also looking at this term here, the leading term is the term that has the highest degree, which is 2. So I'm going to write x squared here. Now x divided by x squared is going to give you 1/x. So since what the definition of the horizontal asymptote is what the rational function tends to as x tends to infinity. So as x tends to infinity, that is as x becomes very large, like 1 divided by 1 million, 1 divided by 1 billion, you'd observe that 1 divided by x tends to 0. So this is your horizontal asymptote. That is, the horizontal asymptote is y equals 0, while the vertical asymptote is x equals -4 and x equals 8. Now there is something you need to note. For the vertical asymptotes, they are equations. It's not just a number. It is not -4 or 8. Now this is wrong, but it's an equation, you can see here. And then similarly, the horizontal asymptote is an equation. You can see it's y equals 0, and that is the very first thing you would note. So let's go ahead and see the demonstration of this function here in a graph. So this is at C189. So let's go ahead and check. So let's punch on, and then let's punch in x minus 4. So let's go to the y editor. So you have your y editor, and then want to go, the first is x -4. So we open bracket, you have x negative 4. So where is our 4 here? And then we close it, then divided by, so we have here is x squared -4x -32. So you have x squared -4x -32. So this is what you have. So this is our rational function here. So we want to graph it. So let's go to graph, and then you begin to see. So you can see now what you'd observe here is this: the vertical asymptote, which is x equals -4 and x equals 8. This is x equals -4 here. You can see it falls in a negative. This is your x-axis, this is your y-axis, this is your x-axis. So this is 1 2 3 4. So this is x equals -4, and then this is also x equals 8. Now what you'd observe about the vertical asymptote is whenever the graph is plotted, it never touches the vertical asymptote, but as it tends to infinity, it looks as if it's getting close to the vertical asymptote, but it never touches it. And then what we have here is the horizontal asymptote is y equals 0. So y equals 0 is just simply the x-axis, but you can see here that the graph crosses, you can see it crosses it here. It crosses the horizontal asymptote here. So that's something you need to note. So for the horizontal asymptote, it is allowed that the graph crosses it, as we have seen, but for the vertical asymptote, it does not cross. That is, the graph can never cross the vertical asymptote. So let us see one more example to ground understanding. So let's see another example. So let's call that example 2. Let's consider a rational function r of x equals, say you have x plus 5 divided by x squared plus 5x plus 6. Now for this rational function, like I told you, before you begin to determine the properties of a rational function, it is always helpful, as your first step is to factorize both the numerator and the denominator. So when you factorize that, what you obtain is x plus 5 divided by, now when you factorize x squared plus 5x plus 6, what you obtain is x plus 2 into x plus 3. So this is what you obtain. So now the next thing is we want to find the domain of the rational function. So like we said, the domain is the set of all real numbers excluding the numbers which, when you substitute them here, they will turn the denominator to 0. So it's going to be, or let me just say, the domain is the set of all real numbers excluding the zeros of the denominator. So that's going to be excluding x equals negative 2 and excluding negative 3, because when you substitute negative 2 and negative 3 here, the denominator becomes 0, and then when it is 0, it's undefined. So the next one, we want to find the vertical asymptote. So to find the vertical asymptote, we said the very first thing is you reduce the rational function in its lowest term. So what we have here is x plus 5 divided by x plus 2 into x plus 3. Now looking at the numerator and the denominator, nothing crosses out, so that implies that the rational function is already in its lowest term. So the next thing is that's the next thing you want to do is to find the vertical asymptote. So simply saying, the vertical asymptote is just the zeros of the denominator. So that is x equals negative 2 and x equals negative 3. Now this is the vertical, that's your vertical asymptote. And then lastly, to find the horizontal asymptote. So we rewrite the function that we're given, that is x plus 5 divided by x squared plus 5x plus 6. This is what we have. So to find the horizontal asymptote, so like we said in the previous example, we need to approximate the function itself. So what do you mean by approximating the function? That is by replacing the numerator and the denominator by its leading term, the leading term. So the leading term is just the term of highest degree. So looking at x plus 5, this is the highest degree here. So I'm going to write x divided by, and then this is the term that has the highest degree here. So you have x squared. So x in x squared, it gives us 1 over x, and then as x becomes very large, so 1 divided by a very large number is going to give us 0. So our horizontal asymptote is 0. So that completes the problem. Now the lesson you will learn here, that is the moral lesson you will learn here, is anytime you have a rational function that is p of x divided by q of x, and the degree of the numerator is less than the degree of the denominator, that is q of x, then your horizontal asymptote, is always y equals 0. Always. Anytime the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is always y equals 0. Like you can see here, we obtained y equals 0, and in the previous video, in the previous example, we also obtained y equals 0, and then that completes the problem. Thank you for watching.